Hey, so I got food poisoning from the dinner I cooked yesterday. So I barely can like move around, but I thought a good way to pass the time is to show you some obnoxious, maybe over-engineered JavaScript. I will show you like the issue I'm trying to solve. So let's say here we have this map data structure, and I just set this object with this key, and now I stored the value in a variable called human. It's here, nothing complex so far, but what I'm doing here is I'm setting another object in the same with the same key again. So this will override the previous one, and to prove to you that this actually overrides it, here is a small check that just gets the current value in the map with the key human one and compare it with the value that I stored here in the previously. It returns false, which means these two objects are different. So this is the normal behavior of the map data structure, but I need a map data structure that if you try to override a value, it will not allow you to do that. It won't throw an error. You can do that, but it won't throw an error. It will just not do it. It will hold the same previous reference. You might ask, what's the use case for this? I mean, I saw a use case, but you really don't need to do the code that I'm gonna do. You can just do if my map that has this key, don't do anything. You can do this everywhere in your code base, maybe if you are not trying to solve this kind of issue. But I kind of wanted to see if there is a way to override the map data structure to prevent overriding values. It turns out if you use the Proxy API, you can, which I have a video about it. I'll put a link in the description, like an introduction to the Proxy API. So here I have my starting code. I have two test cases. So if you do not console assert, if this returns false, it will print these things. If it returns true, or if the first argument is true, it will not do anything. So now if I run this, I should see two log statements, which means I need to fix these two test cases. And the first one is checking. It's similar to the example we saw earlier. I'm storing a value, then override it, and I'm checking if the old reference and the new reference is the same. They should be the same in our data structure because it will prevent you from overriding. And if you set something like this example or this line, the key A will always hold this object. It will never change. That's the idea. Unless you delete it manually, then you assign it again. That's the goal here. So yeah, after we do our factory function that returns our modified map data structure, this will return true. We won't see a log statement. And we will, instead of initializing a map data structure like this, we will just call the factory function. And when we call the factory function, it will always retain the same map data structure it created the first time. So these two, this ref keeper and the new ref keeper, will point to the same object in memory. So this console or this log here will not work because this will return true. So the idea that we only have a singleton map data structure that prevents you from overriding values, that holds the references. That's the main idea. And we will create a factory function that generates this and cache it. So every time you call it, it returns the same cached map data structure. Now to start, I will create a variable. I will call it ref keeper. This will be let, of course. And I will get a type here. And this will be the names are not nice, but I'll call it if map. The keys are a string. The value will be, you can put here anything you want, but I will put a record. The key will be a string and the value will be any. So this is a map data structure. Keys are strings, values are objects their keys are strings. That's it. And this will be from this type. Now, this factory function, each time you call it, it will return to you the same like map data structure if it was created previously. Now, to achieve this, we need to use this. I mean, you don't have to use it, but I like to use the it's called IFI, immediately invoked function expression. It's written like this. That's function that you see this inner function. This will be executed and the returned value from it will be returned. So what I can do here is do this and just call it at the end. Now I will return a function. And this is the actual like factory function. These are like, you can call them a private state for the function. These will only be accessible inside the returned function. And the whole idea here, like this is called immediately invoked function expression. This function here will be returned and assigned to this variable. This function here can access these values, even though you call the return statement here, because this is something called the closure in JavaScript. You should Google about it. It's very nice topic. But yeah, even though you return this object, you return this function still have a reference for these values and types. So what I can do here, every time you call the factory function, I will check if we have a value in the ref keeper. I'll just return it. I will comment these because the red lines. So that's the first point. If you already have it, then return it. The second part is we actually create this and we will use the Proxy API. And we will pass to it this like a new map data structure. And we need to pass map proxy handler and then just return the ref keeper. And we need to create this object. And if you need a small introduction to the proxy objects, I I'll point you out to this video. It's introduction to the Proxy API. It's simulating the magic methods from Python, but in Node.js. Yeah, I think you can watch this video or just read the documentation. But I will try to also explain it here as well. So the Proxy API allows us to intercept and override the default like behavior of objects, and the map data structure. So yeah, like we can override the map data structure. And if you go to the proxy MDN documentation, you see we have all of these functions that we can override. If you override the get, for example, you can intercept every get operation on some object. So here, we have this monster one, we have secret and I count. And each time, like with this proxy handler, each time you try to get like the secret key or the value that is stored in the secret key, we just do this kind of like hashing or whatever. Like here's the example running. You can also override a lot of things. Like you can override if the function is callable, or because objects or functions are objects but callable, you can override when you call them. So in this example, they are using the apply like key in the handler to override calling this some function because they are passing it here. So each time you call it, it will call the same function and it will pass the arguments here and multiply by 10. And here is like a small example of that. So it's a way to override every kind of behavior the functions or objects or data structures in JavaScript behave like. You can just override anything you want. I hope these examples were clear, but if you go back to the get, each handler, like the get, delete, property, construct, this is when you call it, this is when you call a function with a new keyword. But each one of these contains these arguments. target, prop, receiver. We are only interested in the target, and the prop is the property name you are trying to get. So we will be using these two in this video. Now, in our example, the first thing we need to override is the get. I'll just use this. So this will be target, which we know will be from this type. And we will have the name. They call it prop, but I'll call it a name. This will be a string. And here we are overriding the get action, or like the get action, or the getters on this map data structure. Okay. And if you think about it, all of these, if I come back here, the set or the get or the delete, all of these are actually will fall inside the get, the getters, because these are properties on the map object. So all of these things, all of these like methods we can call on any map will fall into the get. So, or will be called, the get will be called each time you try to access any method. That's what I'm trying to say. So what we need to handle here, if you try to like get a value like this, we need to return the value. If you try to call the set, we need to return a function that will actually set the value and prevent you from overriding. And if you try to call any other method, we will just call that for you. That's the idea. So we need to override only the set to prevent you from overriding values. So first thing I will do, so const function, or I will just call it ref, or return value. This will be equal to the target, then the thing you are trying to access. But this will not work in TypeScript as far as I know, because this is a map data structure, and you like accessing these kind of things, it will give you this obnoxious error that I'll show you. I think that's better. Like, yeah, has no index signature. There are multiple ways to solve it. One of them is you just cast it to any, but I found a better way that works with TypeScript. There is the reflect global object. You can pass it like a target and the name of the thing you are trying to get. I'll give it the name. This will give us any, like if you try to call set, if you try to call get, this will give us that thing here. So this could be a function, right? So I'm gonna say const is function will be equal to type of function. So if that is a function and the name is set, I'm going to then function that this function will be called each time you call set. So I'm overriding the set function. It will accept a key, which is a string, and a value. We know our values, I mean, based on this type, they will be of this type. I mean, we defined that. I'll just call target.has. If we have this key, I'll just not do anything. So you can just return a function that returns an empty string. Else, I need to call the actual function and bind this inside the set to the current target we have. This might sound strange, but this will be equal to, or this return value, because I know this return value is the set function. What I can do is just call it and give it the target, the key, and the value you're trying to set. But like this is typed as any. There is a nice way to give it a type. I will just create a function called map set. This will be equal to the return value, and this type will be ref map, and you can access the set type like this. So if I use this one here, and I can get auto completion. So yeah, this is for overriding the set function. Now, if this was just a function, return function, or yeah, I will just return value dot call, sorry, dot bind. I'll give it the target. So for these, I'm just returning the same function, but this argument inside that function is bounded to the target. So this will not fail when you call .delete or .has. And final thing, if you're trying to access any property that exists, like the length or name or whatever on the object, I'll just because this will not be a function, I'll just return this return value. And this should be it. Now for the first test, I'm not getting anything because this map data structure is actually logged. Not sure if the log here will work nicely. Okay, so it's still, you see, we called set multiple times after we are setting the initial value, but it's still holding the same one, which contains this function, say hi. So this is nice. And for the second example, we are calling the factory function again, which based on our logic will return the same map data structure that prevents you from overriding values. We are deleting this key A, which works, and this delete function will be handled here. So we delete, and now we check if these two objects or these two map data structure, this one and this one, are the same. We should not see anything being logged. So that's the idea. It could sound like over-engineered, or I'm not sure, but yeah, I just sometimes get curious about some things, and if they are doable, and I end up with these kind of shenanigans. One thing here that maybe does not look nice is this. You can just, I mean, I'm not sure if the has function or the set function returns anything. Okay, it returns the same. Yeah, it should return the target. So yeah, you should do this. But yeah, maybe as a recap, so we have this immediate invoked function expression that we return from it the factory function we call every time. We have here our private state, so no one can access it from outside this function. And so you call this function, you call the factory function. If we have a map data structure, we will return it. If we don't, we will just create a new one and override every get action you can do. And since this is a map data structure, the get actions, any method you call, any property will fall into the get action. So first thing we do, we get the current action you are trying to access. This could be a function or this could be a value. In case it was a function and the name of the key or the property is set, we return another function that will just basically do, hey, do I have this key? If I have it, I will just return the map data structure as it is. So I'll prevent you from overriding. Else, I will actually call this like set function you are trying to call and pass to it the values you passed. Yeah, and else if this is just any other function like delete, get, or any other function, I'll just call it and I will bind the target with I will bind this keyword from this function I'm trying to call with the target. I'm not sure if we need to do this, but yeah, let's do it now. Yeah, and else I will just return the value. This is for dot size or dot length. I'm not sure if, I think there is, yeah, dot size is a property. This will just return a value, so this will return these kind of cases. We'll handle these kind of cases. I think we can just do this. You don't need to bind it again. This time, if this fails, we need to bind it. Okay, we need to bind it. Okay, yeah, I hope this was like showed you anything new maybe. And yeah. Bye.